So the book that I use actually calls this the Rational Zero Test. One of the things that you'll find in mathematics is different books and different mathematicians call things different things. It's also the rational root theorem. And what this is saying is that your real factors, you can identify them using your constant term and your leading coefficient. Now, as far as this is concerned, it's really just a starting point. It's a starting point for you to identify what numbers to use in synthetic division. That's what this is, okay? So you don't have to go crazy and memorize it. It's called the rational root theorem. But what you do want to know is you want to be able to know that this is where you start, okay? So that's what the rational zero test is telling us. So right here, this a sub 0 right here, that's your constant. That's always the number that doesn't have a variable with it, okay? This right here, that's your leading term. That is the coefficient in front of your highest exponent. That's what that is right there. P is going to be factors of this term. Q is factors of that coefficient. Okay? Now, what I tell students to do when they are looking at this, okay, the rational root theorem, this particular book also calls it the rational zero test. Your possible rational zeros are factors of the constant term over factors of the leading coefficient. Again, this isn't something that you need to have memorized. It's a way for you to eliminate numbers that you don't need to check when you're trying to do synthetic division. That's what this means. So here we've got x to the fourth minus x to the third plus x squared minus 3x minus 6. This is a polynomial that we cannot factor. We cannot factor using the AX method. We cannot factor using grouping. We have to use synthetic division on this, and I'm not telling you what to divide by. The rational root theorem allows you to figure out what numbers make sense to try. That's what this theorem allows you to do. So what I tell students to do is always start with factors of this number. I tell students to always start there. Sometimes it gets more complex because we have a coefficient in front of the x to the fourth. In this situation, our coefficient is just 1. So tell me a number that it would make sense to try to see if it works using synthetic division. Just a number that would make sense. Number 2. Why? Choose a factor of 6. What's another number that makes sense? 3. What's another number? 6 itself. What about 1? What about negative 1? Negative 2, negative 3, and negative 6. That's it. I was helping a student yesterday, and we had synthetic division, and I can't remember, maybe this number right here was 20. I think it was 20. You think it was 20 when we had it with the x minus 7? And I immediately said, we're going to have a remainder on this one because I know it doesn't go into it evenly because 7 was not a factor of 20. Okay? So this helps you to not go in blind. Now, in this situation right here, you're asked to factor it. And so we have to start. So we're going to start with 1, 2, 3, 6, or negative 1, negative 2, negative 3, and negative 6. Okay? Sometimes you have to do synthetic division several times before you find out what it is. But what I want you to realize is that this rational zero test or rational root theorem gives you a place to start. That's why we do that. It gives us a place to start. Okay? We are going to start with factors of this. That's what we start with. And so we said it could be plus or minus 1, 2, 3, and 6. And I know you're looking at that and you're thinking, Alicia, that is 8 things that I might have to try. Okay? But it's way better than not knowing where to start at all. Okay? So I am going to start, well, it doesn't matter where we start. Where do you want to start? Positive 1? It's always easy to start with positive 1. Let's start with positive 1. Okay? So I'm going to start with positive 1. And remember, using synthetic division, I'm writing down my coefficients. So I have positive 1, negative 1, positive 1, negative 3, and negative 6. I am trying to factor this, is what I'm doing. Okay? That is my ultimate goal here, is I want to factor this so that I can find my zeros. Okay? I'm going to bring down my 1. 1 times 1 is 1. Negative 1 and 1 is 0. 1 times 0 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 3 and positive 2 is negative 1. 1 and negative 1. Okay, what does this tell me? What does this right here tell me? Oh, I messed up. Tell me what I messed up.
1 times 0 is 0.
Yep. Right here? Thank you. Thank you, thank you, thank you, thank you. Okay. 1 times 0 is 0, and I get 1 here. So I just messed up everything. Okay. 1 times 1 is 1. Do I get negative 2 here? 1 times negative 2 is negative 2, and I'm left with negative 8. Okay. What does the negative 8 tell me? No. Okay. It tells me that 1 not a solution. What is not a factor? X minus 1 is not a factor. That's what that tells me. It's not going to work. Okay? So, positive 1 didn't work. What else? What should we try next? 2. Let's try 2. Okay? And I'm trying 2 because it's a factor. And a lot of times on these tests, I have students erase this. They kind of erase all this. And then they put a different number here. And that's completely fine. It's completely fine. Okay? So now, I'm going to bring down my 1. 2 times 1 is 2. Negative 1 and positive 2 is positive 1. 2 times 1 is 2. 1 times 2 is 3. 2 times 3 is 6. Negative 3 plus positive 6 is positive 3. 2 times 3 is positive 6. Okay. What does this tell me? What does this tell me? It is a solution. Okay. So this tells me this is a solution. Okay? So if positive 2 is a solution, what is my factor? I heard it. X minus 2. Good. So 2 is my solution. X minus 2 is my factor. Okay. Now I have to write my remaining polynomial. Okay? I have to write my remaining polynomial. Right here is my remainder. What is this? Constant. Good. What is this? X. X squared. X cubed. Perfect. You got it. Okay? It always goes in that order. Remainder. Constant. You can also think of this as x to the 0 power, but sometimes that confuses students a little bit, but that's essentially what's happening here. X to the first, x to the second, x to the third. Okay, now, very, very often after you do synthetic division once, you're able to factor the rest of it. So we've got plus 3, we have x here, x squared here, x to the third here. Okay, so I can rewrite this as x to the third plus x squared plus 3x plus 3. Okay, so what this means is if I multiplied this binomial times this polynomial, then I would get this up here. Okay, now I'm going to keep going. So I'm going to factor x cubed plus x squared plus 3x plus 3 off to the side. And I'm going to say, okay, what goes into x cubed and x squared? X. What else? X squared. Good. So x squared goes into both of those. So then I'm left with x plus 1. Okay, what comes out of the next two terms? Okay, so now I've got x plus 1 times x squared plus 3. Now, I can't factor x squared plus 3 any further. I can't factor that any further. But I can set it equal to 0. And that's what I'm going to do, is I'm going to set it equal to 0. So here we go. I'm going to erase this factoring right here. So I have x minus 2 equals 0. X plus 1 equals 0. And x squared plus 3 equals 0. Okay, now, when I solve x squared plus 3, I end up with x squared equals negative 3. When I take the square root of both sides, and I end up with x equals something, what do I end up with? X equals... Good. And what do I have to put in front of that? Plus or minus, okay? That's the important part. You've got to put x equals plus or minus the square root of negative 3. Now let's talk about why. Just for a couple of minutes. Just for a couple of minutes, I want us to talk about why. If I've got x squared equals 4, and I take the square root of both sides, students immediately say, oh, x equals 2. Okay? But what is the other number that x can also equal? Negative 2, because negative 2 squared also gives me 4. So it's important when I'm left with x squared equals 4, when I take the square root of both sides, you've got to remember to write down that plus or minus. Okay? You've got to write down that plus or minus. So your answer here is x equals plus or minus 2. our situation right here, I've got x squared equals negative 3. Take the square root of both sides. I'm left with x equals plus or minus the square root of negative 3. So don't forget that plus or minus. Now, what's that negative 3? What do I have to pull out? I. Okay, so that right there, that's 2 solutions. I have positive I on the square root of 3 and negative I on the square root of 3. So you need to recognize this as 2 solutions and this as 2 solutions. Okay? So my solutions here, so that plus or minus square root of negative 3, I'm running out of room. So I've got x equals 2, x equals negative 1, and x equals plus or minus I on the square root of 3. So here is one solution right here. X equals 2. Is that real or is that complex? Does it cross the x-axis? Does x equals 2 cross the x-axis? Yes. Does x equals negative 1 cross the x-axis? Yes. Does x equals plus or minus I on the square root of 3, does that cross the x-axis? Who says no, it does not? Who says yes, it does? Who has no clue? There's a lot of you that didn't vote. Okay. It does not cross the x-axis. Okay? This does not cross the x-axis. Plus or minus I on the square root of 3 is a complex solution. It's a complex solution. If we were to graph this, and I'm going to graph it right over here. I'm sketching it. I'm not graphing it. It's a very, very loose sketch. Okay? So while we're sketching this, let's go ahead and remind ourselves how to sketch. Okay? If I have an even exponent, and I'm sketching, are the ends of my graph going to go separate directions, or are they going to go both? Both. Both up or both down. So when my leading coefficient, or I'm going to say leading term, when it's positive, which direction does it go? Both up or both down? I heard it. Both up, okay? So here we go. Okay, now that squiggly in the middle just means we don't have any clue what it's doing. Okay? But we know the end behavior is both up. If I have a negative leading term, what do I know about my end behavior? Both down. Okay? And this is a good review for your quiz and what you're doing this afternoon or today. Now, for me personally, even exponents are way easier to deal with than odd exponents. Okay? But odd exponents, I always think about lines when I get back to odd exponents. Okay? So here, I'm going to put kind of in parentheses, both ends, same direction. Okay? Maybe up, maybe down. Okay? My odd exponent, think about slope of a line. So, odd exponent, the ends go in different directions. Ends in different directions. Okay? My ends are going in different directions. Now, if it's positive, I follow the slope of a positive line. So I start at the bottom. I don't have any clue what it does in the middle. That's when I have a positive leading term. When I have a negative leading term, it follows the direction of a negative slope, and it goes that way. Super important that you've got that written down in your notes. You might have it written down a couple of times. Okay? Super important right here. Now, this one right here, we know my leading term is 1x to the 4th. I have an even exponent and a positive coefficient. So both are going to go up. That's what that means. My end behavior is both is going to go up. Now, my graph crosses the x-axis at 2 and negative 2 because those are real numbers. Real numbers, and this is probably a good thing to star, real numbers cross x-axis. Complex numbers do not. Okay? Real numbers cross the x-axis, complex numbers do not. So I've got 2 and negative 1. So I'm crossing here at negative 1, and I'm crossing here at 2. I also know where I cross the y-axis. Where do I cross the y-axis? How did you know that?
Because it's the only one without the
Good. Your y-axis, your y-intercept is always the one that doesn't have any variable with it. Okay? So in this situation, our y-intercept, where it crosses the y-axis, is negative 6. Okay? Now, do we have any multiplicities other than 1, where it does funky stuff? Do we have any multiplicities? We don't. We don't have any multiplicities. So this graph, let me go ahead and do 1, 2, 3, 4, 5, 6. Okay? So it goes something like this. Now we don't know. I mean, it's going to do something weird because of those complex numbers. When we're doing our darn good sketch, we don't know exactly what that behavior looks like. So when I say a good sketch, I'm looking for x-intercepts, behavior at x-intercepts, y-intercept, and direction of graph. Okay? That's what I'm looking for. My x-intercept, my behavior at x-intercepts, my y-intercept, and direction of graph. What do I mean behavior at x-intercepts? What does that mean? Good. Yeah, you're exactly right. Okay, so when I'm talking about behavior, I'm talking about multiplicities. Multiplicities. Now, the one that we just did, everything showed up one time. We had a multiplicity of 1. So if I have an odd multiplicity, my graph crosses x-axis. Okay, if I have an even multiplicity, it touches x-axis and changes direction. Okay, so that's another thing that you probably want to have a picture of as you're sketching graphs. Okay, so one more thing that I want to talk to you, and then I'm going to let you practice. I want to talk about conjugate pairs. Conjugate pairs. We had two things going on over here with x squared equals 4 and x squared equals negative 3. Okay? When I did x squared equals 4 and I figured that out, how many solutions did I get from the x squared equals 4? 2. Okay? And when you've got x squared equals something, you're always going to get 2 solutions. That's called a conjugate pair. Now, it's super important that you realize you always have conjugate pairs when we've got complex solutions. It is impossible for you to have I on the square root of 3 without having negative I on the square root of 3. Okay? So this right here is called a complex solution. Complex. Okay? Complex. Okay? They always travel in pairs. Now, for the problem right before us, we had x equals 2 and x equals negative 1. Those are rational solutions. Rational solutions. Rational solutions are completely independent. You don't have to have the opposite of it. So 2, what's the opposite of 2? Negative 2. So 2 and negative 2. We don't have to have both of them because it's a rational solution. You only have to have its opposite when you're talking complex and irrational. Now, irrational are real numbers, okay? But they're not a rational number. An irrational number is like the square root of 2. There's no I in it, so this is real. You would see where it crosses the x-axis. But it has to have its conjugate. Okay? So we've got real and we've got irrational. These travel in pairs. So real and irrational travel in pairs. Square root of 2 is real and irrational. This is complex. So we've got kind of two different things. So complex is where we've got imaginary. Complex involves I. It does not cross x-axis. Does not cross x-axis. Okay? So this right here is complex. It does not cross the x-axis. And it does travel in pairs. This is real, but irrational. And that just means we've got the square root sign in it. It also travels in pairs. Okay? Real, irrational, crosses x-axis. Then we have rational solutions. Rational solutions are real. They cross the x-axis. Okay, alone. Okay, and a rational number is anything that can be written as a fraction. So in this situation, I've got positive 2 and negative 1. Okay? I could also have 2/3 or negative 1/4. These are all rational. They do cross the x-axis. They do not travel with its partner. You might have its partner, but it does not have to travel with its partner. Okay. Okay, so this is a good one. This is a good one for us to look at because we're going to do one more, and then I'm going to set you loose on practice. Okay. What numbers would we start with for this one? What are reasonable numbers to start with? Factors of 60. There's going to be a lot of factors of 60. So when you're dealing with a number this high and you're not allowed to use a graphing calculator, because if I were allowed to use a graphing calculator in this situation right here, what I would do is I would graph it. That's what I do all the time. Okay, you're not allowed to use a graphing calculator, so if you were given a situation like this, I'm going to tell you the first zero. So I'm going to say, find all the zeros of this if, I don't even know what it is. The first one is 3. 3. Okay? So I want you right now to do synthetic division for 3. 3 does work. I gotta write down when I told you guys I'd do review session. Did I tell you 3? Okay. Where did I mess up? Didn't I do the same thing earlier today? There we go. Okay, how are we doing? Did you guys get this? Okay, so what do we do next? I'm open to suggestions. Okay.
And I chose 2.
Okay.
Because it factored into both 20 and 6.
Okay.
And I ended up with another.
Okay, did 2 work?
Yeah, it
Okay, I did not get that 2 worked. I got that negative 2 worked, but I did not get 2. Are you sure you didn't do negative 2? Okay, and that's fine. Did anyone say, ooh, let's use the quadratic formula? Did anyone think about that? I'm glad that no one thought about that because that's not right. Okay, you cannot use the, you can't use the quadratic formula here because your x is to the 3rd power. So you can't use that. Okay? So you have to do synthetic division again. Now, sometimes students get confused when they do synthetic division again because there's not an x squared value. So when you do synthetic division again, you have to accommodate for that x squared. Was it negative 2 you used? It was, okay. So negative 2 works. Negative 2 works. So I could put negative 2, and I am doing synthetic division here. Okay? So I have a coefficient of 1, 0, 6, and 20. Okay? So I go down, I bring my 1 down. Let's see if I don't mess this up this time. Negative 2 times 1 is negative 2. 0 and negative 2. Negative 2 times negative 2 is positive 4. 6 and 4 is 10. Negative 2 times 10 is negative 20. So that works. So then I've got, this is what I've got now, x minus 3 times x plus 2 times x squared minus 2x plus 10. Okay, and I need to erase some stuff. Can I erase everything above my red? Okay, now, once you get here to x squared, so I have x minus 3 times x plus 2, and then I have x squared minus 2x plus 10. Once I get here, I can't factor x squared minus 2x plus 10 anymore. Okay? And I can't use synthetic division anymore. I have to use completing the square or the quadratic formula. I will give you the quadratic formula on your test. You do not have to have that memorized. You have to know how to use it, but you do not have to have that memorized. Now, x minus 3 and x plus 2, x minus 3 and x plus 2 give me 3 and negative 2 as solutions. X minus 3 and x plus 2 are the factors, but the solutions are 3 and negative 2. I've got to find the solutions associated with this quadratic, and I can do that using the quadratic formula or completing the square. This is a nice one to do completing the square. So I'm going to remind you how to do completing the square. Okay, so I do x squared minus 2x plus 10 equals 0. To complete the square, I keep my x squared and my minus 2x on one side. I move that positive 10 to the other. So I've got negative 10 on the other side. Okay, then I take half of negative 2. What's half of negative 2? I heard it. What's half of negative 2? What's half of 2? 1. Make it negative. Negative 1. Then we are going to square negative 1. What's negative 1 squared? Positive 1. So I am going to add positive 1 to both sides. Okay? At this point, I can factor my left-hand side. I have x minus 1 squared equals negative 9. I can take the square root of both sides. That's what I'm doing next. I'm taking the square root of both sides. When I take the square root of negative 9, what do I have to put in front of it? Yes, good. Plus or minus. So then I have x minus 1 equals plus or minus. I've got negative. What's the square root of negative? What's the square root of 9? 3. So this is plus or minus 3i. And then I bring the x, the 1 over. So then I have 1 plus or minus 3i. So my solutions, and because of this plus or minus, I want you to realize this is 1 plus 3i. This is 1 minus 3i. We have a complex solution. It does not cross the x-axis. It always travels in pairs. That's what this is right there. So my answer to this, what this question is saying, find all the zeros. That's what it wants. Find all the zeros. This is my answer. Now, I'm writing this separately so you can identify them as two different answers. You do not have to write them separate. If you write it like that, you're fine. Okay. This is as bad as it gets. Okay? It doesn't get worse than this. I promise. So, what I want you to do right now, and you've got 25 minutes left, I would encourage you